Another way that we can think of a plane is that we can start off with some two vectors. So let's say this is vector u and vector v. And then we can look at the plane that contains these two vectors. Now we can see that the equation for this plane should be something times u plus something times v. So the equation for this guy should look like u times something. So let me just say, let me just use variable s here. So it's going to be u times s plus v times something. So it's going to be v times, let's say, t here. So now this is going to be the equation for my blue plane here. Let's notice how this u and v, this is the orange vector that I start off with. And my s and t, this is just the variable. So s and t, this is a scalar, it's a variable. And in general, this vectors u and v here, it can start off at any point. So let me actually just name this point q. What I have to do is just add q to the equation that I have here. So if I add q to this guy, this now is going to be the equation for this plane. So that's kind of what we have here. If the plane goes to the point q, whose coordinate is x0, y0, c0, and it's parallel to two vectors u and v, then this plane is going to have this equation. So again, u and v, this is going to be my two vectors. So I use a boldface letter to mean they are vectors here, and then my s and t, this is my variable. Notice how we can view this point q as a vector as well. So I can think of x0, y0, c0 as just a vector. So in technical terms, this thing is actually a vector value function. Vector value function. Because I can think of q as a vector, and I can think of, so u and v, this is already a vector. I multiply this vector by a scalar. So I'm basically adding up these three vectors here. Now, this is actually not only vector value, it is also vector value parametric function. Because I'm going to have 3D functions, and it actually has two variables, f and t here. Now, before I do the example 6.5 that we have down here, let me actually point out real quick that this thing, u times something plus v times something, it actually has a name. This thing is actually just the span of u and v. So it's just some linear combination of u and v, by the way. So it's just a span of u and v. And that actually kind of makes sense because linear combination of u and v, something times u plus something times v, are basically vectors that will go on in this kind of blue plane here. So now let me do this example down here. I'd like to find an equation of the plane that goes through these 3 points. So let me kind of sketch this. So 1, 2, 9. So let me just say it's here. 3, 2, 7. So I'm just gonna pick a random point here. 3, 2, 7, and then 1, 4, 13. So this 3D graph is going to be a little hard to draw on a piece of paper. And I like to find the equation of the plane that goes through this three guy. So it looks something like this. Let me kind of move down a little bit. Okay. Now to use what we have here, notice that we're going to need the coordinate for the point q, and we're going to need two vectors u and v here. So let me just name this 1, 2, 9 my point q. And let me just make this and this my orange vector. So let's see what is the coordinate for my orange vectors. So this guy will just be, let's see, 3 minus 1 is 2. And then 2 minus 2 is 0. And then 7 minus 9 is negative 2. So this is the coordinate for my first orange vector. And for my second orange vector, the coordinate is going to be 1 minus 1, which is 0, 4 minus 2, which is 2, and then 13 minus 9, which is 4. So now I have the blue point. I have the blue point, which is here. And I have the two orange vectors. So I can already write the equation from my plane. So it is going to be just 1, 2, 9 plus the first vector, which is 2, 0, negative 2 times something. So let me just call it S. Plus the other orange vector, which is, 0 to 4. 0 to 4 times another variable t. So now here is already my equation for this plane. Now, I said earlier that this is actually a vector value parametric equation, because if we look at it in another way, if we look at this guy in another way, I can kind of expand and write this out. This is going to be just, If I look at the first coordinate, that's going to be 1 plus 2s plus 0t. So that's just 1 plus 2s. And this is going to be my x coordinate. The coordinate for y is going to be 2 plus 0s plus 2t. So that's going to be 2 plus 2t. And the coordinate for my z is going to be 9 minus 2s and then plus 4t. So here, these are my coordinates for x and y and z. So I can kind of write this out as a parametric equation, as x is going to be just 1 plus 2s, y is going to be just 2 plus 2t, and then z is going to be just 9 minus 2s plus, 4t. So here is another way that I can write the equation for this plane. Now, well, before I finish, let me also talk about another way that I can write the equation for this plane. So let me now kind of move to the side. Let's say we have this blue plane, and the starting point here, my point Q is going to be 1, 2, 9. And I have these two orange vectors, which are 2, 0, negative 2, 2, 0, negative 2, and 0 to 4. Okay. So what I can do is, I can actually look at the normal vector, which is the vector that is perpendicular to this plane, as just a vector that is perpendicular to my two orange vectors here. Now, in three-dimensional space, there is a way to find a vector, the black vector, that is perpendicular to the two orange vectors, and this can be done by computing the cross product. So I can compute the cross product for these two guys here. So let me say, so the cross product is going to be just I and j and k, and then 2, 0, negative 2, and then 0 to 4. So if I were to compute the cross product for this guy, I'm going to compute the determinant of this matrix, and that will give me, this is going to be 0. So if I multiply down, I'm going to get, this is going to be 0, this is going to be 0, and this is going to be, 4k. If I multiply up, I'm going to get 0 here. I'm going to get negative 4i, and I'm going to get 8j here. So then the determinant for this vector is going to be, negative 4i, and then plus 8j, and then minus 4k. So that means the coordinate for my black vector here is going to be, the coordinate for this black vector is going to be negative 4, 8, negative 4. So now we see from the previous example that if I have the coordinate for the normal vector, I can already write the equation for this plane. It's going to be just negative 4x plus 8y minus negative 4z equal to something. So now I only need to find this something. This is not for YC, this is just for C. And now I only need to find this something, and I can do that. So we usually use D, so let me just write D. And we can do that by just plugging in the value 1, 2, and 9 into X, Y, and Z here, because this point has to lie on this plane. So if I do that, I'm gonna get negative 4 plus 8 times 2 is 16, minus 4 times 9 is 36. And then, so I'm gonna have 14 minus 36, which is negative 20. Negative 20 minus 4, so that's negative 24. So my D is negative 24, and I'm gonna have negative 4x plus 8y minus 4z is negative 24. If I divide both sides by negative 4, I'm actually going to get, let me see, x plus 2, x minus 2y, x minus 2y plus z equal to 6 plus c equals to 6. So this is another way that I can obtain the equation for this plane that goes through this 3 point that the problem have. Notice how the answer here, x minus 2y plus c equal to 6, this is actually just the same plane that we see in the earlier example. So if I pull out my graph here again, this is what I'm looking at. My blue plane, notice how this blue plane goes through the 3 point that I have, which is 1, negative 2, and 1, wait a minute, not this one, which is 1, 2, 9, the blue point here, 1, 4, 13, which is the orange point here, and then 3, 2, 7, which is the orange point here. So my blue plane indeed goes through the 3 point that the problem have. And the 2 orange vectors that we have seen earlier are this vector and this vector. Now how about this black vector here? This black vector, 1, negative 2, and 1, this is the normal vector to the plane. So we can notice how this is the normal vector, is perpendicular to my plane here.